Hello class, welcome to our lesson today. We're going to switch gears a little bit and do an application of graphing, which deals with what's known as harmonic motion. The main application of this is something like pulling a spring down and letting go, and it has kind of an up and down movement. Okay, think of it kind of as that situation. So this is the one application that we're going to be looking at. There's a kind of one set of formulas and rules that you want to follow, and then hopefully we'll be able to apply those into each situation. Here's all the information for simple harmonic motion. The key thing is that this should look similar to like A sine B of t, but notice that this is that omega that we looked at earlier in the semester with angular speed. That's because that omega is still angular speed here, so it's the same variable. But you can treat it just like the B value that you have before. So to find the period, it's 2 pi divided by B, or 2 pi divided by omega. A is still the amplitude. The one new thing here is what's known as frequency. So frequency, notice, is just the reciprocal of the period. So if the period is 3, the frequency is 1/3. And what that tells you is how many oscillations, or how far it's going up and down, how many times back and forth it's going per second or per unit of time. So the new part is this frequency piece, but it's just the reciprocal of the period. Okay, the first thing I want to look at is giving an equation, find the amplitude, the period, the frequency, etc. So the amplitude is the number in front, that should be the same. The period is 2 pi divided by the B number, or omega, and that's 2 pi over 3. And then the frequency is just the flip of the period. The most common mistake is that students want to take the 3 and just flip it and say, oh, it's 1/3. But it's the period's reciprocal to be the frequency. For this next one, there's a few kind of twists to it. First off, the amplitude idea is still the same. So if it's a negative up front, the amplitude is still 8. It just means instead of starting above the x-axis, it's going to start below. And we'll kind of go through what that means in an application here in a little bit. The other thing is that the omega or b value is 2 pi over 5. So 2 pi divided by 2 pi over 5 is multiplied by its reciprocal. And so that'd be 2 pi times 5 over 2 pi. And so 5 is the period. And a lot of times these equations will have omega or b values that have pi involved, because you want the period to be something like 5. In this case, this could be 5 seconds or 5 minutes. So typically, you'll see a lot of that as we go through this lesson. If 5 is the period, then the frequency is the reciprocal, which is just 1/5. So remember, the period and frequencies are reciprocals of one another. Okay, the next problem has some information, and you have to write the equation. So the easiest thing to do is to deal with the second part, which says S of 0 equals 0.42. Now remember, our formula at the very beginning was S of t equals. Okay, so this formula, S means position. In some science realms, it's probably more obvious what that represents, but S of t means position. And so it's saying position at time 0, which is the initial position, which would be the y-intercept, which is the amplitude number because cosine starts above the line. So that 0.42 would be the amplitude, the number in front. Then the only thing we need to find was this omega number. We find that by setting 2 pi over omega equal to the period of 25. Multiply omega over to the other side, divide by 25. So 2 pi over 25 is that number with omega. The really nice thing about this application is there's no phase shift and there's no vertical shift. Everything's centered around the x-axis. So that's a really nice thing for all of us, that we don't have to worry about those two things. The next question has S of 0 equals negative 0.23. Now here's what this is meaning. The last one was 0.23 and this one's positive, and this one was negative 0.23. The first one is like if you took a spring and kind of shifted it upward or compressed it and then let it go. You're building the tension and then letting it go, and then it drops. This version is saying take the spring and pull it down so you're below the equilibrium line. Okay, so the negative just tells you pulled down first instead of compressing upward. Notice this one says the frequency is 105. Now, you could set this equal to the frequency formula, omega over 2 pi. I'm going to probably tend to just make it the period, because a lot of us remember that formula better. And so if the frequency is 105, the period is 1 over 105. and then I set that equal to 2 pi over b or 2 pi over omega, cross multiply and solve, omega will equal 210 pi, and that's the number that's going to go inside the equation for the omega number next to the variable t. You can do that either way, you'll get the exact same answer. I just tend to go the period route because I'm used to using that formula more, and you might find it the same way. Okay, so here's an example of the spring. So it says the spring is an object attached to the spring. It's pulled down a distance of 5 units. That's the initial position. So S of 0 is down 5, but we have to know that down 5 means negative 5. Then it's released, and the oscillation is complete in 4 seconds. So think about it. It takes 4 seconds to repeat itself. That's an oscillation. So the period is 4. So the easy thing to do is say, oh, well, if the period is 4, the frequency is 1/4. And what that's saying is you complete 1/4 of the oscillation every second, which matches to the fact it takes 4 seconds to complete one full oscillation. The position formula, -5, because the initial position is -5. Cosine, the period is 4, so I set that equal to 2 pi over omega, move things around, and I get pi over 2 for omega, and I plug that in, excuse me, and my formula then is S of t equals -5 cosine of pi over 2 t. Using that formula, they're asking you to find the position at 1.5 seconds. You just plug in 1.5 for t. You need to remember that you have to be in radians for these questions. So make sure that your calculator's in radians. Try out that equation. Hopefully I plugged it in right. I know sometimes I have a slight error when I plug things in, but hopefully this one's right. So plug that in radians and make sure you get that answer. The other question that you might see is something about maximum or minimum height. You don't have to have a perfect sketch, but what you need to have figured out is what does a cosine graph look like? So typically a cosine graph starts above the x-axis, goes down and comes back up and completes one oscillation. Since your initial position is negative, it's flipped around. Okay, so it's got an x-axis reflection. So it starts at -5, goes up, comes back down in 4 seconds. So in that whole time of 4 seconds, the first half of it, from 0 to 2 seconds, is on its way upward, and then at 2 seconds hits its maximum spot and it works its way back down. So because of that, the object will reach its maximum height at the halfway point of 2 seconds. If this was a compression one and it was the opposite, it started above, the question would be when would it meet the minimum height? And it would still be the same 2 seconds because it's that halfway of the period. So when you're looking for a max or min height or anything like that, it's probably the halfway point of the period. The only time it may not be is, let's say for this question they said, when will the object reach its minimum height? Then it's the full period distance. But it's got to be one of those two things as you're looking at those questions. Make sure that you're looking at the formula. S of t equals the amplitude times cosine of omega over t. And remember that omega is the same as the b value. It has this specific application because of angular speed being used in some of these questions. Have a good day, everyone.